Hello, this is the third video in the laboratory orientation series, and in this one we'll be focusing on ethics and data integrity. In the previous video we talked about the importance of quality, integrity, and credibility to environmental laboratories like Apple in establishing relationships where their customers are going to bring business back. And while these policies and procedures are important first step in ensuring quality results and data integrity really boil back down to the analysts conducting the analysis in the laboratory. Data integrity describes what's required or why we can trust data, and it requires that the data is of known quality, that we have procedures in place so that we know that the data is good, that we're not just expecting it, but we know it. And it requires that the data be defensible and usable for its intended purpose. Now, to be useful in showing that you're meeting EPA regulations, it has to essentially comply with those policies. It needs to be defensible in the sense that you know and have established and can show that this analytical result came from this sampling event at this location at this time. Now, some of that is outside of Apple's control, such as that the sample was collected properly, stored properly, and transported properly. But a lot of it is within Apple's control. And Apple is motivated and required to document and track that data to show that so they can defend it in court, essentially. And when you look at data integrity, it really boils down to two key concepts: is the people doing the work behaving ethically, and effective communication. And if you have breakdowns in communication and material isn't documented properly and communicated properly, you can have a problem with data integrity. If the people aren't doing what they're supposed to and behaving honestly, you can have significant problems. So that the personal angle, or the human angle of this, is the ethics. And ethics, broadly speaking, is just a system of moral principles governing the appropriate conduct for a person or group. And what the moral principles or the appropriate conduct is depends a little bit on the discipline. There really is a concept, as we start to look at applying this in environmental labs, that there really isn't a right way to do a wrong thing, that isn't possible, but what right and wrong is needs some clarification. In a scientific laboratory, wrong would equate to scientifically unsound or technically unjustified procedures, whether it's omission of information, manipulation of data or information, alteration of procedures, not following the written procedure, even if it seems like it ought to be okay. If you're not following the written procedures, if it bypasses the required quality control parameters. Now, keep in mind that written procedure was validated. Deviating from it goes outside that scope, so all of a sudden you're outside quality control parameters. And all of this would be, in most cases, with the purpose of making the results appear acceptable. It's conceivable that it could be with the purpose of making results appear to be unacceptable, but more than likely it's with this purpose of getting things to pass. Improper practice can fall into a couple categories. Broadly speaking, plagiarism counts. While it's not as common in an environmental laboratory, representing your work, someone else's work as your work, amounts to plagiarism. This can be failure to cite information properly or acknowledge other people's contributions. It's not as much of a problem in environmental labs, where fabrication and falsification are much bigger issues. Fabrication is essentially creating data that you did not collect properly, jotting down a temperature of what it should be rather than taking the time to measure what it actually is. It could be falsification of data, so tweaking some things here and there so it works. Maybe it's manual integrations and switching to manual integrations to make something pass. Maybe it's swapping out a quality control sample. Those types of information where it's not the same as fabrication, but you are falsifying or changing the data. It could be suppression, and this is one that a lot of people don't see initially as a problem, but if you have a bad result, if a run doesn't work and you rerun it and write over the files, that is suppression of data. That mistake could have been relevant or important in a procedure, and by omitting it or blocking it, you create a problem where evidence can't be tracked and you can't follow that chain, and so suppression would also amount to an improper practice. Now, one type of improper practice is fraud, and you need to be careful about the distinction between fraud and mistakes. Fraud is purposeful, it's intentional, okay? It's a misrepresentation of information with an intent to deceive. Okay? And these are all difficult or hard things to prove in court. And often the difference between honest mistakes and fraud has to do with how those mistakes are documented and what documentation is generated. And so as you're going through the rest of your training, you'll see some examples of what documentation is required when corrective actions are needed, or ways that you can document problems with samples properly in computer systems so they're tracked for reporting. This scale of honest mistake to fraud really bears some discussion. Keep in mind this is distinct from the severity of the problem, as you can have an honest mistake that causes a major problem, and you can have fraud that doesn't seem to have a significant impact. Again, the difference is that intent. If you are caught committing fraud, the consequences are severe. In addition to jeopardizing employment, jeopardizing future employment due to credibility issues, jeopardizing the laboratory's brand and putting the laboratory in legal jeopardy in some sense, you can also personally be convicted and sentenced to up to 5 years in prison per count, and $500,000 fines. And this changes a bit from state to state and federally. The source for these numbers are the Oregon Technical Advisory Committee, but the numbers are roughly correct regardless of where you go. And notice that these can sort of pile up. Is first making a false claim is one sentence. When that false claim is on a report that's shipped through the mail or transferred electronically, you add more. When you do not correctly answer questions about it, you add more. And so this intent and how you handle mistakes becomes very important. Now, if they're going to try to put you in jail, the standard legal burden of proof would be that they would have to establish beyond a reasonable doubt that you've committed fraud and that you're guilty of it. And this is on a continuum of beyond a shadow of a doubt, beyond a reasonable doubt. As you have less and less evidence, you end up towards burdens in the neighborhood of reasonable suspicion. But it's important to note the damage to your credibility and the laboratory's credibility doesn't require any of this. The simple appearance of improper conduct can be enough to cause significant problems for you and the company. And so how do we handle and deal with these situations? And it really boils down to reporting and documenting things that could appear to be misleading and avoiding things that could appear to be fraud. So let's talk through some examples of how these things can naturally come up. I think everybody agrees that if you make up your data, that is bad. I think everyone can agree that if you get a number that is above a method detection limit and you change the number in the computer system so it is below, that is bad. Let's talk about some subtler cases. Let's consider a peak integration. Your surrogate level, say in a GC method, falls slightly above the method's acceptance criteria, and that says you have to redo the analysis because it doesn't pass. On looking at the data, you notice that the automatic integration is drawn poorly. In this example, it's going from the bottom of the noise to the bottom of the noise, and you're adding a big chunk there, and you say, well, that's why it's failing. It isn't really too big, it's that the integration is poor. And so you come along and you manually integrate the peak where it is, sort of center of noise to center of noise, and all of a sudden it's good. And so by manually integrating, you're able to make it pass. And is that acceptable? Now, that would seem to be a justified change, but if it does not comply with and follow laboratory policy on manual integrations, then it is not. And it really gets down to that intent of why did you manually integrate the peak. If you manually integrated the peak because you were following procedures, then you're fine. If you manually integrated the peak because it was not possible to rerun the samples for one reason or another, and you note that this peak was, the automatic integration did not work, and you manually integrated the peak at which time this happened, and you communicate that deviation, non-conforming work, in the case narrative and to your supervisor, then you're okay. It's documentation there. If the purpose was to make it pass as opposed to generate an accurate integration, then it would be intent to deceive or manipulate the data. In this case, you can make a solid case that it is not properly integrated and your intent is to get an accurate number, but you need to clarify and pay attention to documenting and communicating those items so that it does not appear that it could be fraud. Let's consider another case. The normal receiving staff are out sick and you're helping check in samples. It's a busy day, a lot of coolers came in, and you realize that you just completely forgot to measure the temperature blank in the cooler to ensure that the samples were received below 4 degrees. But they were on ice. It has to be less than 4 degrees, and you mark it as less than 4 degrees because, really, it's on ice. Is it possible? This would be an example of falsification, okay? Or fabrication, sorry. That data was not collected and you are making it up. You may have a solid justification as to why, but you are making up the data. A way to deal with this same situation where you failed to collect the data at the time the sample was received and measure it following the procedures, and perhaps this is in the procedures, you could put in the case narrative that the samples were received on ice and the temperature is presumed to be below 4 degrees, but it was not measured. That disclosure or documentation, same reasoning, same impact, because it was clearly documented and documented as non-conforming work, would be valid. Okay, so you make a mistake and you forget to measure it. How you deal with that mistake and how you document and follow up on it is the difference between a mistake and fraud. A counter example is if you don't want to be embarrassed, you don't want people to think you aren't paying attention to what you're doing, and so you just write in the less than 4 degrees. No one will ever know. That is fraud. That's deception. Another example, let's go to ICP emission and metals section, and the blanks in your most recent batch show 22,000 part per billion calcium and 5,600 part per billion magnesium, but really you're only reporting iron for these samples and there was no iron in the blank, so you're done, right? There's nothing to report. Is there a deviation you should report on your case narrative? And technically, I suppose, that if there's no iron in the blank, it doesn't affect your analytical results. This is an example where you need to use your common sense, and it doesn't make sense that a deionized water blank should have 22,000 part per billion calcium. These levels are much more consistent with well water, and it points to the possibility of a sample swap. It points to the possibility of other problems that may be relevant in other cases or other situations. And so while technically there's no need to document something on the case narrative here, this is something you'd want to note. You'd probably want to rerun the batch to see if there was a mistake and see if you could catch it. But at a minimum, notify your supervisor that you have this potential issue. And so in this case, it may not be an intent to deceive at all. It may just be a, hey, I'm not thinking about it as it goes by. And this clearly you have data that points to something being wrong, even if it doesn't affect your analytical results. The point in these examples and the discussion exercise that you'll do following this is you need to start thinking ethics. There's definitely the black and white end. There's also a lot of grayscale, and it's how you make decisions and document those decisions in the laboratory that protects you from accusations of fraud and protects the laboratory and their reputation. The areas of concern, or some things brought up by the Oregon Technical Advisory Committee in their ethics training, is a good sort of run through of where you might see problems. Data manipulation and tweaking data to deal with samples that are slightly out of bounds. Failure to follow SOPs. And it may seem really dumb to you, but little things like the brand of the standard being different. If it specifies a specific brand in the method, you have to use that brand. You don't get to swap. If it specifies crimp top vials and you have screw top vials, that's non-conforming work. Most procedures and most laboratories have a way to deal with situations like that, and perhaps you simply disclose that the samples were run in screw top instead of crimp top vials. But you can talk with your supervisor and manager about how to ethically and properly document those deviations. Falsifying existing data, of tweaking that data. Improper calibration procedures, playing games with the calibration so it works better. Inappropriate manual integrations, and really watch out if you're going back and reintegrating peaks. Really watch out for that. Manual integrations are an area that is very easy to raise suspicion of improper practice, so make sure if you're doing manual integrations you're following the established written policy. Watch out for overwriting files, shaving peaks, enhancing peaks, deleting peaks or files, all of those things. Even if you think that data isn't relevant anymore because you reran it and it worked, watch out for overwriting and deleting files. Incomplete training can be another area. And that may not be that the training is actually incomplete, but if the documentation process hasn't been completed, then it appears that you haven't been properly trained. Incomplete record keeping, that you've left out samples. Perhaps you reran samples or dealt with a problem or established that something wasn't proper but didn't include those records in the file. It can then appear that there is fraud or non-compliance with the policy. Mislabeling or swapping samples can cause trouble. The demonstration of competency is related to the training, but you should not be analyzing samples if you have not passed and completed a demonstration of competency. Reporting data for samples not analyzed, I think, is cut and dry. If you don't know that's wrong, you have a problem. Selective use of QC data. You don't get to choose which 2 blanks you use. If you ran 3 blanks, you need to consider 3 blanks. Spiking samples after they're prepared. I think that's another cut and dry one. It didn't pass, so you add a little bit more and run it. That's not appropriate. You need to watch out for time travel, and what's meant here is changing times and dates on instruments or in databases. Now sometimes you enter a date improperly. You didn't notice that the computer clock was off and it doesn't match and you're correcting it. You need to be sure you do that properly and according to procedures. Like most things, if you're not sure if it's okay, talk to your supervisor. And as you handle or report problems at Apple, you should talk to whoever you're comfortable talking with. Ideally your supervisor. They're most familiar with your methods, but suppose we have a situation where you feel that your supervisor is putting undue pressure on you to get results out and is happy to have the quality go down because they just need to get it done, and you're not comfortable reporting or talking to your section supervisor. You can choose to talk to the lab manager. You can choose to talk to the QA manager. You can choose to talk to the president. Or if you feel that it's a problem at the laboratory as a whole, you can make a confidential report to the outside counsel, and you'll find that information in the quality assurance program and the ethics statements. As you're choosing who to talk to, be careful to have specifics and specific examples. That makes it easier to start the follow-up investigation. That's one of the responsibilities of the laboratory. You have a responsibility to follow the quality procedures, to pay attention to what's going on, to watch out for potential problems or the potential appearance of a problem. The laboratory has a responsibility to take these issues seriously, to have clear policies and procedures in place, and when there is a report or a concern about a deviation, to investigate that confidentially. Quality is first at Apple and should be at every environmental laboratory, and you're not going to get in trouble for raising concerns. You will get in trouble for hiding mistakes. If you have any questions about quality, be sure to discuss them with any of these individuals. And the next part in this training is an interactive discussion, and these discussions should include a minimum of 2 people, and go over at least 2 of the scenarios listed in the training manual.